5th International Physics Olympiad, year 1971, IPHO. Problem number 1. A triangular prism of mass big M is placed one side on a frictionless horizontal plane as shown in the figure. The other two sides are inclined with respect to the plane at angles alpha 1 and alpha 2 respectively. Two blocks of masses M1 and M2 connected by an inextensible thread can slide without friction on the surface of the prism. The mass of the pulley which supports the thread is negligible. Express the acceleration A of the blocks relative to the prism in terms of the acceleration A0 of the prism. Find the acceleration A0 of the prism in terms of quantities given and the acceleration g due to gravity. At what ratio m1 over m2 the prism will be in equilibrium. 5th International Physics Olympiad, year 1971, IPHO. Problem number 2. A vertical glass tube of cross-section S equal 1.0 square centimeters contains an unknown amount of hydrogen. The upper end of the tube is closed. The other end is opened and is immersed in a pan filled with mercury. The tube and the pan are placed in a sealed chamber containing air at the temperature T0 equal 273 Kelvin and the pressure P0 equal 1.334 multiplied by 10 power 5 Pascal. Under these conditions, the height of mercury column in the tube above the mercury level in the pan is H0 equal 0.70 meters. One of the walls of the chamber is a piston, which expands the air isothermally to a pressure of P1 equal 8.00 multiplied by 10 power 4 Pascal. As a result, the height of the mercury column in the tube decreases to H1 equal 0.40 meters. Then the chamber is heated up at a constant volume to some temperature T2 until the mercury column rises to H2 equal 0.50 meters. Finally, the air in the chamber is expanded at a constant pressure and the mercury level in the tube seals at H3 equal 0.45 meters above the mercury level in the pan. Provided that the system is in mechanical and thermal equilibrium during all the processes, calculate the mass m of the hydrogen, the intermediate temperature T2 and the pressure P in the final state. The density of mercury at temperature T0 is ρ0 equal 1.36 multiplied by 10 power 4 kg per cubic meter. The coefficient of expansion of mercury beta equal 1.84 multiplied by 10 power negative 4 opposite kelvins, and the gas constant R equal 8.314 joules per mole and Kelvin. The thermal expansion of the glass tube and the variations of the mercury level in the pan are not considered. Hint: if delta T is the interval of temperatures variations of the system, then beta delta T equal x, which is much less than 1. In that case, you can use the approximation 1 over 1 plus x approximately equal 1 minus x. 5th International Physics Olympiad year 1971 IPHO. Problem number 3. 4 batteries of EMF E1 equal 4 volts, E2 equal 8 volts, E3 equal 12 volts, and E4 equal 16 volts. 4 capacitors with the same capacitance, C1 equals C2 equals C3 equals C4 equal 1 microfarad, and 4 equivalent resistors R are connected in the circuit shown in the figure. The internal resistance of the batteries is negligible. Calculate the total energy W accumulated on the capacitors when a steady state of the system is established. The point H and B are short connected. Find the charge on the capacitor C2 in the new steady state. 4th International Physics Olympiad year 1970 IPHO. Problem number 4. A spherical aquarium filled with water is placed in front of a flat vertical mirror. The radius of the aquarium is r, and the distance between its center and the mirror is 3r. A small fish, which is initially at the point nearest to the mirror, starts to move with the velocity v along the wall. An observer looks at the fish from a very large distance along a horizontal line passing through the center of the aquarium. What is the relative velocity v real at which the two images of the fish seen by the observer will move apart? Express your answer in terms of v. Assume that the wall of the aquarium is made of a very thin glass. The index of refraction of water is n equal 4/3.